I'm really happy to be on call with you today. I'm excited to talk about your company, Diamond Age.
Yeah.
You co-founded.
Yep.
Uh,
Yep.
Really cool company taking a fresh spin on an industry I've been covering for 3 years on YouTube, 3D printed construction.
Mm-hmm.
You can see up there it says automate construction. So
Yep.
when I see new parts of the job getting automated, that gets me even more excited. So to hear you guys have 27 different attachments that you're using on your gantry system, or you hope to use, I saw that was the initial plan. You have
Yeah.
at least a handful of them in action already.
Mm-hmm.
I don't even know where to start.
I think the easiest thing to start is one, my wife and I watch you. We always check in YouTube when we're watching Netflix and stuff and just say, oh, what's Jared got going on? So, do appreciate what you're doing for people out in the field. And I think the biggest thing we look at this is that there's a lot of people in the field doing a lot of hard things, right? Which, take a step back, housing needs to change, right? Hard things to build houses these days, not enough labor, costs, all of that fun stuff. Diamond Age, in the way Jack Oslin and I, my partner, and then my other partner, Paul Clark, and a couple of other co-founders that I might talk a little bit about, looked at this and said, look, we got to build houses, and houses haven't changed since, people say 100 years, but if you go back and I think the thing for us is you go back to like Levittown right after World War II, and most builders know about that, on Long Island, big first true like master planned communities. You put those people in a time machine from 1947, 1948, you bring them to an existing job site. A DeWalt is a little bit different, a Bostitch nailer is different, a laser level and an iPad, but by lunchtime they'll be a pretty functional crew, and by the end of the day they'll probably be craftsmanship level work going on from those people if you had that magical time machine. So to have people transported 70 or 80 years into the future and take 4 hours to get up to speed says stuff hasn't changed.
Yeah, it's an interesting analogy. And one of the other fascinating parts of your company is your history at Tesla. They're like the king of automation historically. So your role there, you were a production director?
Yeah, Tesla's a funny story. I've been in factories my whole life, and I've been watching Tesla for a while. So I got a chance to go work for them in 2014, kind of really early in the Model S launch. And I was asked to go and fix kind of operational engineering for powertrain, which was about 30% of the value of the car. So motors, batteries, chargers, electronics, cabling, and went in there and pretty quickly put together a killer team and turned that around pretty quick. Did that for almost a year and a half until the beginning of, I turned the engineering around, and then the guy who brought me in, this amazing guy, I'll just give props, a guy by the name of Andy Hamilton, who's now working with JB Straubel at Redwood Materials. Andy was the director that hired me. They asked Andy to go fix another part of the factory, and Andy asked me to be the director of powertrain. So I did that for about a year and a half. So that was about 1,500 people in the powertrain factory. And then there's a bunch of staff changes early in the Model X launch. And Elon asked me to go run the S and X assembly, which I did that for him. And we got that up and running. We put out a lot of cars, kind of hit the quarters we were supposed to, and then asked me to launch the Model 3. So I took my team, and I had a pilot team build the first few hundred Model 3s, and then with the manufacturing engineering, the design engineering, all the people there, it's a giant team environment, helped to roll out the 3, and then kind of that was my time to tap out. Tesla is very intense environment and fun. Like, I made some amazing friends. I learned a tremendous amount of stuff, and really just helped who I am as a manufacturing leader. But it's a very big life commitment to be in Tesla that deep. And so I decided to tap out like end of 2017. But it's really interesting. So I worked directly for Elon for a while. That was fun. He's amazing. Taught you a lot, but he will kick the crap out of you every day to make you better. And that's why he is who he is, So people at Twitter are learning that. But, My thesis has never been against Elon. Never.
Yeah, that sounds incredible. And so we don't have to dwell on that too long, even though
No.
it's super interesting to me. My one question about it would be, is the perception from the outside true? Is it really in engineering, like, or is it a special place for engineering where it's different than the other companies around the
Oh,
world?
absolutely. Yeah, yeah. And I think the easiest way to say that is Elon and all the teams around him have the ability to attract amazing talent. And when you
Mm.
attract amazing talent, that rising tide raises all boats. You've got to be good. And if you're not good, you get gone pretty quick. But so you're going to work with some of the best people you've ever worked with, and you're going to do some really hard things. So yeah, it definitely is different. It's been, like I said, so I was out of there late 2017, right at the end of the year. So it's been going on almost 5 years now since I've been out of there. I still know some people in there, and they still continue to do incredible things. There's good and there's bad. Like any big company, doing lots of painful things. Some people are going to have a bad experience. Some people are going to have a good experience. But, at the end of the day, I never served, but we have a ton of veterans on the team. And you talk to these vets in the Marines and the Navy and the Army guys, and they all say everyone hated boot camp till the day you graduated boot camp. Then it was the best thing you ever did. Right. So,
Yeah.
and one of my co-founders, a guy by the name of Paul Clark, he says it all the time. He's like, Tesla was a great place to have worked. So that's about as much we talk about that. But we do have about 7 or 8 co-founders here that all came at my time with Tesla, and they were all in the trenches. We were all in the trenches together. So when we rolled this thing up, that was the team we picked to roll it up.
Yeah, there's a certain, I guess, team bonding experience just from giving it your all and staying late hours. And it's something that maybe is rare these days when there's less life-threatening situations in the United States. And yeah, it's a special thing. And so with Diamond Age, you started the company I heard about it first like maybe a year ago, 6 months to a year ago. But how long were you operating in stealth mode before that?
We started this in 2018. So,
Yeah.
the kind of the origin story is our CEO. So I'm CTO. Jack's our CTO, and then we've got a couple of the other co-founders in critical roles. So Jack and I met my early days at Tesla. Actually, rented a room from him and his wife. They were trying to put their his stepdaughter through grad school. So living in the Bay Area, most people know how expensive it is. So Jack was rolling a startup, living the startup life, spending his own money on his own startup, and so I ended up renting from them, and they're amazing people, and they just treated me like family. And they would invite me down for breakfast on Sunday morning, or if I walked in at 9 o'clock at night, Jack would hand me a beer and then like, here's half a steak from the fridge, eat. And just started talking about engineering problems. And he was rolling up a company called Plenty, which is one of the biggest indoor automated agriculture companies that Jack had founded. And we just kind of got talking around the kitchen table about engineering and kind of bonded over that. And I helped Jack with some early engineering problems and brought in some of my friends that I knew that could solve some problems, and did a bunch of work to get Jack's thesis and some of his early stuff a little tighter for him. And and it just became kind of a bonding thing. And as I lived with them for about 10 months, and then Jack and I just kind of became fast friends, and we'd always talked about doing a startup, and did I want to go work for Plenty, but I was in Tesla at the time. But anyhow, 2017 came, I left Tesla, I went and built drones for a while for a pretty interesting company, and Jack was always whispering in my ear, hey, there's something out here. And we tried a couple different exploratory things, but Jack kind of created the housing thesis. He had kind of a life-changing conversation with his son, talking about moving out of the Bay Area because they couldn't afford a house, and his son was a recruiter at one of the big self-driving shops, and his daughter-in-law was a nurse practitioner at one of the biggest research hospitals on the other side of the Bay. I'm not going to talk about companies, but they're an amazing couple. And
Sounds like they should be able to afford a house with those jobs.
100% in any reality except the Bay Area, right? So, that kind of was Jack's call to arms, and we started really talking about the housing thesis, and we saw what some people did, like super early icon work, and we started looking at housing, and we said, hey, people are onto something here, and Jack was smart enough to kind of take us and say, look, let's go talk to people. And we spent about 6 months on a listening tour, and we went and talked to land developers and structural engineers and architects and materials people, and all the conversations were, you're crazy, but that might work. And so we kind of rolled with it, and it got a little bit of momentum. We Jack put together a business thesis, I pulled together a technology thesis, and we kind of beat the hell out of it and said, how do we make this work? You're going against the biggest industry in the world. Jack had already conquered agriculture in his last startup, and the only thing bigger than agriculture is construction. And so did that, and finally said, hey, I was building drones for about a year, and some amazing founders, a really amazing company. It just wasn't the right fit for me, and so I was like, all right, time to jump out of that. And we both threw some money in a checking account and self-funded this thing. And I went to all my compatriots at Tesla that I kept in contact with and said, look, guys, we're going to go do something really crazy, going to spend a bunch of money. And we rented a shop, bought a bunch of equipment, and started experimenting. And all the folks from Tesla, did a bunch of help, a tremendous amount of work with us, and they got paid in beer and scotch and Red Bull and chicken wings, and did that for about 2.5 years. And we came up with a working prototype, and shopped that around to some of the venture capitalists in the Bay Area, and finally hit with a couple of really impactful companies, and launched that funding. And that allowed me to take all the people and convince them that, hey, Tesla's amazing, but come do this, come be a founder. And I had quite a few people from that Tesla time that said, yeah, let's go do this. And that's where we got the funding, and we rolled up and built that first prototype house and all of our equipment, and proved out all of our tech through the end of 2021.
So at that point, some of the other guys on your team, Jack, they had other startup experience. Mm-hmm. It was your first startup?
Well, I worked at, the drone startup I worked at. I got in there, and it was pretty small at the time.
Not as a founder?
Not as a founder, no. I worked for the founders, and the founders are amazing guys. But like I said, we just wasn't a right match. And that's, when it's small, and you're, I was a manufacturing leader for them, and it's small, and you have to have really, really good alignment, which was, I had lived with Jack, so I knew him pretty well. All right. So we knew we got along. And then the folks that had come in from Tesla and a couple of the other companies in the early team, we had all worked together. So you get to know everybody's what the fudge face, right? When something breaks, or it's 2 a.m. and it doesn't go right, and I'm stomping around going, what the fudge? Everybody knows, all right, give him 5 minutes, he'll calm down, and then we'll go solve this problem. Where if you just kind of meet people, and some founders just kind of randomly meet, and you don't know people's reaction when times get tough. But everybody that had worked at early Diamond Age, the sub 10 people, we knew each other. So we all knew idiosyncrasies, we knew people's abilities, and all of those abilities focused on everybody could weld, everybody could machine, everybody could design in CAD, pull electrical wiring. So we were all builders. Jack was mixing concrete. We did everything ourselves, and we continue to do everything ourselves. So that was the key, is that early team set the culture, and we're kind of a culture of builders. Like, everybody we hire has hands-on, to the machine. There are no department managers. There are no directors. We're already growing pretty decent size, but everybody's intimately connected to the work. And that's how you roll a startup that can move this fast.
So it's a similar organizational structure to Tesla, like flat organizational structure?
Tesla was, from what I know, like I worked with a lot of people that were at the San Carlos days in my early 2014 and 2015. I would say, and it's probably punching up, but I would say we're kind of like that Tesla San Carlos phase where everybody was super connected to the work. Once you get big, you start getting into the thousands of people. Yeah. When I was at Tesla, there was 5 levels of leadership that I had to steer below me. Right. You had line leads and supervisors and associate managers and senior managers and directors. It's like, you have to be that big to run a company that gets to be 20, 30, 40, 100,000 people. But, in the early days, I wasn't there, but I worked with a bunch of the people that were at San Carlos, and it seemed like they had it really tight and really well done, of connected and really capable people.
Yeah, that's great. And it sounds like from your experience, you have the most, you're the most, I guess, tried in the scaling up of the manufacturing. So now that Diamond H has printed a couple homes, you're probably looking towards, okay, how do we get 100 printers? And that's what you've done before, right?
Yeah, just by the fact of being the oldest, save for one other guy on the team. Yeah, I have the most experience. But like before I did Tesla, I did factories all over the world, and built dozens of facilities and factories. So and scaled them, and that was all fun stuff in packaging, where you're making 5, 6, 8 million pieces a day. So that's given us good perspective, and some of my early founders came from similar backgrounds. But we have my our kind of operational leader, Paul. He's one of the early co-founders. He's an amazing home builder. The guy just lives and breathes home building, and second generation general contractor. Funny story, went to Cal Poly and said, I'm going to be a mechanical engineer. I don't want anything to do with the home building business. Graduated and immediately bought a home building business. So, but I was able to pull him out of the home building industry and bring him into Tesla, and and a bunch of the other people. And we have some of my folks on my software team. We just have a pretty amazing spread of people. I've got the guy who writes our software is he's a Navy nuke. He was running nuclear reactors on aircraft carriers, and he was one of the youngest officers ever in the nuclear Navy, which is an incredibly smart assemblage of people. So to be one of the youngest ever to hit his rating, smart, capital S, underlined, bold, and italic. And it's a guy by the name of Adam Hoke. He was working with me at Tesla, and we have mechanical engineers extraordinaire that all of them Tesla. So all came together. Like I said, Tesla was an amazing aggregator of talent, and but at the end of the day, everybody said, "Hey, this is great, but we want to be able to say we built this from the scratch." So those original 10 people just really have set the kind of tone, that culture, and the heart of the company. And it's been really fun to mirror that. We're building, and we're getting pretty decent size right now, and we've seen that continue to mirror that. Everybody we bring in is someone who's done something hard in their career. So it's fun.
Yeah, and I'm sure when you get started, like Tesla with the Roadster, you're not making everything yourself from the get-go, but you're using what you can and figuring out what are the first things you want to make yourself that you can improve. Ultimately, I guess you guide towards making everything yourself. Are you making things like the stepper motors yourself already?
No, so we build everything in-house, but again, I'm not going to go gearboxes, stepper motors, logic controllers, network cards, things like that. So all of those things are bought off the shelf, but we build our own electrical cabinets. So we design and build and wire all of our own electrical cabinets. We build our own wire harnesses, but no point. There's amazing tech out there, and steppers and servos and positioning and sensors, but we are truly ground up. Like, we do everything in-house. We don't shop anything out. I think in the close to 5 years we've been doing this, we've sent out maybe $30,000 worth of parts for manufacturing. Just one, we just did not want to buy the machine to do one operation, and the other one, the machines we did have, we were running them around the clock, like people sleeping next to the machine and waking up and reloading the machine when it was done. So we just said we need more capacity, and we paid somebody to do it. Besides that, we've actually got amazing machinists on staff. We got a pretty well kitted out machine shop. We've got some of the best welders you'll ever come across. So we focus on the people. You bring in the people that can do it. And when Jack and I were paying for everything, it was 2 weeks for a prototype and $500. And now it's 2 weeks and $5,000. That's the only thing changed, right? You get a little bit more money to spend on prototypes, and but you don't get any more time.
Yeah. And I guess you're prototyping a lot of stuff all at once. Of the 27 attachments, how many are, I guess, at a beta operational status?
8 right now. So
Wow, that's a lot.
Yeah. So, and it all goes sequentially, right? Like if you look at this, there's no point in me trying to engineer something or engineer a prototype that would have the robot waiting 9 days on the job site, right? So right now we're doing early stuff of preparation for the slab. Slabs are what they are. They're never flat. They're never straight. They're never plumb, true, and level. They're good or bad. We've got some good slab contractors working through us, through our contract, through our our customer. So they do the best they can, but so how we date them to slab with equipment, and then how we prepare it, and we do some really different technology on the wall system. So we do some drilling automatically, we do scanning, post-processing. So we actually cut some of the concrete, insulation, rolling trusses. So some of the stuff that we've been doing is all early in the house build. And then, as we go along, we have the balance of where something is in the build sequence. So that kind of stack order from slab to front door keys, all that kind of sequential process. And then what's either the safety aspect or the labor reduction aspect. And that's how we kind of prioritize on tools.
Nice. I'm in a Python course right now just to keep learning stuff. And I've noticed everything goes wrong all the time. Everything, if I try to write too much at once, I can't even figure out what the problem is because there's 6 different problems. So the construction sites I've seen, 3D printed construction sites I've seen, it's kind of similar. It's like an early technology. So they're figuring stuff out. They're thinking things through and doing things for the first time. Often they figure out improvements. I think pretty much every job site I've seen, they figure out some improvements that day, a whole list of them. So even like the goal is automation eventually, as much automation as possible, but to get there is an arduous, challenging engineering feat that is, I think, a lot of times left behind the camera because companies want to wait until they have something really, I guess, perfect to show. But can you tell any blood, sweat, and tears stories of the challenges behind the scenes?
Oh, thousands of them. I think back up to what you said, right? Everything you do is going to generate problems. And the question becomes are you generating problems faster than you're solving, right? It's just sometimes yes, sometimes no. Somebody smart said to me, if you're not embarrassed by your first effort, you're waiting too long, right? You're never going to get it perfected in the shop. You're never going to get it perfected in the lab. In our production yard, you go out to the field with it, go out to the field and, no equipment survives first contact with its field role, but we've gotten really good at that. We've gotten really good at saying, okay, this is at 60%. Let's go see will it hurt anybody? Okay. No. All right. As long as it won't hurt anybody, let's go try it. I can knock down a wall. I'll rebuild the wall. I can bend a part on the machine. I'll make a new part, but I just can't hurt people. Right. So, so getting that early contact with process and with product is key, and I have some great stories like truss lifting, we're putting truss lifting in, and that was a really quick prototype tool and doing it kind of uniquely. Right. So we have some IP around it, but first job, the guys who were framing a house next to us, we finished a house, so they were doing a roof next to us. They were like, oh my God, that's amazing. That's fun. Right. And we rolled trusses in about 3 hours and didn't need to bring a crane on site, didn't need that. And we learned a bunch of stuff. We just learned, hey, how do you engage with the truss? How do you, stability and all of those things. But, on the downside, pick anything we've ever done, we give you a little insight. We started a house June 6th and got a certificate of occupancy August 10th. Right. And wow. in that time, we were printing at 116, 118 degrees. Right. And, running shifts, pretty long shifts, and a lot of dedicated kind of our operations team. We call the guys out in the field, we call them industrial athletes, because it really is like, it's an understatement to call them a production associate or a machine operator. These guys are top level athletes to be out in the field and to do what they do. And it's a team out there, but, so printing through dust storms or working through and taking pauses for lightning, OSHA's got a bunch of rules, like there's lightning anywhere in the air, you got to stop. We're sitting there with big giant grounding rods sticking up out of the ground. And, so, going through that weather and learning how to care for people first, and then the machine, the machine was built pretty well. But how do you stage people, and how do you give those people rest breaks, and how do you do those things? So that was a big learning process. And, the fun part of that is everybody came out of that stronger. We have still a lot of the original people that we brought in for these industrial athlete roles. They're still on the team, and they're psyched as hell. They own a part of the company, and they're just like, let's go, let's build. And so, those are the type of things. But on equipment, yeah, you could point to any piece of equipment, and we've broken it, we've twisted it, we got it wrong. But again, it's how quick you react and how quick you can walk away from something that's just not going to work.
Does the thickness and height, which are both particularly large on your system of the layers, help with the printing in heat environments?
Yeah. It's interesting because we're actually, we use pretty large aggregate. We're quite differently with how we do it at extrusion. I don't want to talk down and through that too much, but our layers are 2.5 inches wide, 2.5 inches thick, and we think there's plenty of room to move on that in either dimension. So it definitely helps, but because it's really just machine cycles. If I wanted to lay down a 1/2 inch layer, I'm going to lay down 200 layers to get to 8-foot high wall. Right, so it was chosen. We thought that was optimal size to kind of build, but be able to handle things. Concrete's a tough material. Concrete's tough in the heat. It's a living material. We recognize it's one of the most studied materials on the planet, but it definitely is. It's alive and it reacts to its environment. And we think we've figured out a way to have concrete cooperate us. We're never going to beat concrete into submission. You're not going to beat Mother Nature. You're not going to beat chemistry, but we get the concrete to cooperate and do what we need to do, and that's part of the wall structure, and it's part of how we've engineered the equipment. And that's the one thing is we're truly materials agnostic. We basically roll up to a quarry and we just go get a sized grade material and we get a concrete sand. We don't need any special ash. We use fly ash as a greenhouse gas offset, but we don't need any special volcanic ash. I know a lot of people out there doing amazing stuff, but some of the mortars that they need to use and where they're trucking it in, all the things you've asked people on your interviews, right, is like, hey, where is this material coming from and how much does it cost? And I'm like, pick a quarry in a 30-minute radius of the house. I'll send a guy there. He'll whip out our spec sheet. And that afternoon, I'll have dump trucks rolling and rear dumping 25 tons of material, and we're off to the races.
When I hear that, to me, it means batch plant mixer.
Something like that, yeah. We do batches, right? And obviously because the conditions change during the day, and we've dialed that in pretty well. And most people are doing that. I see the guys who are doing continuous pumping and different stuff, and some of the equipment that you guys have shown. Kudos to them. That stuff is hard. Like rolling process changes are not easy. So those folks are out there doing hard things. We do it a little bit differently, but at the end of the day, we always said concrete is a very, very globally utilized material on a very local scale. Rock is different from every quarry. Sand is slightly different from every quarry. We actually started out throwing Saccrete in the machine, and like I said, I give people the challenge. If my guys were up to it and I had the time, I'd bring a skid of Saccrete in from Home Depot, and I would bet after the third mix, my operators would have it dialed in and get the strength and have it coming out of the machine. They would know how to do it, and we have enough process history and process control that if I wanted to, I could use Saccrete, but too expensive. And we don't want to handle
that sounds
bags.
Promising. And right now your strategy is mostly operating the equipment. Will you be selling printers to builders?
No,
never.
No, our thesis is if you look at the home building cycle, there's 3 major parts. There's the dirt part, dirt to kind of, get a plat. So you get your layout, you get all your approvals, what house you're going to put on what plot. You have the build cycle, so you go from dirt to front door keys, and then you have the sales cycle. And you look at those 3 cycles, the sales cycle is super hard, right? You've got to get potential homeowners, get them cleared, get their loan to value ratios, your debt. Hey, call this medical debt and get this taken off of your credit report, right? The home builders are amazing at driving those relationships, and especially the one we're working with. They drive those relationships. They get people in houses. That is a very high touch business, and for me to say I'm going to be an engineering company and do that would be crazy, right? They really have that dialed in, the sales cycle and the marketing, and they know what people want to buy and the architectural aesthetics. So we stay away from the front end of that customer. And then on the back end, the easiest way to go broke is to speculate on dirt and say, hey, I'm going to buy this cotton field out here in Arizona and I'm going to convert it. But, that can take 2 years, that can take 5 years, that may never happen with water rights. So we let the home builders play the dirt and development game to go, look, they know what amenities people want in a community. They understand proximity to who's building what new factory. So they do that front end, and we come in that middle. We get bookended, and we say, look, once you have that plat, the community design, what houses you want to build, give us the house design. We'll take that house design because it's not my thing to tell them architectural aesthetics. They say, here's your 1,600 square foot plan. I'm going to say, hey, I'm going to move these 6 walls. I'm going to make this a little narrower, this a little wider. Here's your same plan. 2 out of 100 people would notice the differences, right? But we have to change it. Obviously, you know what construction looks like on 3D printed walls. Some are double white, some are triple white. So we don't tell them about what their architecture is. That's not my job. We just tell them this is how I'll build your architecture. And then we go and we take it from dirt and we build it and we hand them back front door keys. And that's our business model is doing that. And the idea with that is to own the equipment, put the equipment out in the field, train the people, and be able to have those home builders turn on and off our capacity as needed.
So when they specify a need for a vertical load column for a truss, how do you solve that?
You know, it's interesting. Every wall we build is a load-bearing wall. We don't build non-load-bearing walls. So in our wall construction, which you've got a lot of strong IP suite around it, we've done some really neat things in the wall that every load's a load-bearing wall. So when I take a house and I'll, take any of the big name brand builders that we all know and love, right? We just take their plan and they say, look, this is going to be on this size foundation. It's got this building setback lines. We go through and we have a couple of amazing, we have an architect on staff, structural engineers on staff, a couple solid people like that. But we work with a really tight knit crew of outside firms. They're all professional engineers and they know how our walls are built. So they go, okay, I'm going to build all these walls. Here's a sliding glass door. Here's the garage. This is how your wall will handle that. And it really is just kind of they just pull out of the Diamond Age toolbox and say, this is the wall you need to support that load. And then, again, my partner Paul says, we're just different from slab to top plate. So in between the slab and the top plate, we're different. From the top plate of the house up, we're the same. It's roof trusses, it's all of the HVAC. And from the slab down, out here in the desert Southwest, all the slabs are post-tension because of expansive soil. So we're just different in between right now.
Are you running utilities through the slab pre-construction?
Just drains, just water and drain. We do all of our electric in the wall, so everything's buried in the wall. I don't know if you've seen this out there. If you go look for it, you can find this kind of the Matterport view of the Diamond Age house. Honestly, the interesting thing is if you walk in a Diamond Age house,
you can't tell.
Can't tell. That's the idea. Is like, I think people need to have familiarity. People, we look at it and it's funny. I just say, look, there's apartments right around where our factory is, our shop is. And I go, look, the narrative is the young family that's in an apartment, they pull up the early pregnancy test. It's got the blue sign and they're like, wow, we're in a 2-bedroom, 1-bath. Where's my mom going to stay when she comes to help us? Right. And that's the driving event. People go, now I need a 3-bed, 2-bath. Right. And we're trying to build for those folks. We're trying to build that first house in this country. And Jack's got that really special drive in saying, look, people used to be in their mid-20s when they got their first house. Now it's driving to mid into late 30s, and you lose 10 years of appreciation. You lose 10 years of that compound interest on that capital that you've spent on a house. Most people don't own a lot that's an appreciating asset. Cars are not appreciating assets, right? Furniture, but homes and stocks, right? So the problem that we're trying to solve is get people back into their mid-20s when they can afford their first house, because in this country, most people's retirement plan is their house, right? Mm-hmm. And so, until you can put enough product in the market to help change prices, that's going to just either stay the same or get worse.
So are you achieving that continuous vertical load with the backfill of a different kind of material or some foamcrete insulatory structure?
Yeah, we're a composite wall structure, so there's a bunch of patents around that, and it's a little bit different. But we've found a way to take a few different components from different parts of masonry and panelized construction, and put it together in a way that flows really well from an automation standpoint. That is very familiar to building inspectors. I mean, I'm out here, like I said, I've already gone through I've built in 2 different municipalities already, and we just educate them. They're all great people, but a building inspector's job is to provide life safety conformance, right? At the end of the day, building inspectors, their primary job is not to worry if the house is leaky on air, right? Their primary job is to make sure that house doesn't fall down in a big windstorm or a big snow load or a hurricane, right? That's why building codes exist, is to protect life safety. So, we've put this wall system together. We educate them on, hey, this is the child of these 2 or 3 different techs put together. Here's all the calculations. Here's all the loads. Here's the professional engineer stamp from that third-party engineer, so that engineer is certifying this wall structure will hold up to these 145, 150 mile an hour winds, will hold up to this seismic load. And, that's where we've really, really succeeded, is we bring in the inspectors, we educate them, and we work right alongside them. And there's no special exceptions for us. We just show up and we're another builder. We're weird, but we're another builder. So we still have to, roll up with PE stamps, and we still have to build how we say we're going to build.
How has the insurance hurdle been?
Insurance has been pretty good. Again, it's all about getting out there, getting in front of it. Job site insurance and all of that. We're construction. We're doing some stuff. So, we have those same workman comps that all the other contractors would run to. We have our safety program, and all my guys have gone through OSHA 10 training and some on OSHA 40, and the typical things you do to run a contracting business.
And then homeowners insurance.
Homeowners, we're educating people, and there's a great level of interest from the insurers and then the reinsurers, the people that insure the insurance companies, because they see this as a departure from what they know, and they're really, really interested in it. They see all the structural engineering calculations and go, okay, all of our testing that we've done, and they go, look, this is a really interesting product. They just don't know how to take it yet.
Yeah, I'm sure they want to come up with a number. They want to do business. It's hard to come up with that number, I guess, for a new product.
Yeah, but, they just look around and they go, hey, at the end of the day, it's a CMU. It's a masonry block home to them, right? So they know what that house looks like. So that's kind of the categories we're in right now. And but we think long term that as we get out there and we do some more education, that, we think about the problems. You see all wildfires, and you see everybody that lives at that urban wildlife interface. That's where all your fires are. You look in LA and all up through the West, is that there's a potential here to say, all right, change some roof materials to less flammable, and, get fire rated doors and windows that don't look like the pull down gate on a deli, right? Get something that's architecturally nice. And you look to the Gulf Coast, there's some stuff like that for storm shutters. We think we can easily get to a 2-hour fire-rated house.
Mm-hmm. So right now, you're working on building a group of homes in Arizona. Mm-hmm. Is it that's separate from the 72-unit project? Or
yeah. So we've done. We've done one quick demo project because, again, the builder we're working with is just absolutely amazing. They just have been the best partner, and they really see where this tech helps them get more people into homes. So we came out, and again, we have the same inertia that other people do, getting permits, getting plats, getting all of the connections ready. So we came out, we built a group of small group of houses just as that quick turn demonstration. Now we're building out a whole community of 48 houses, and then on the heels of this one, so mid to late summer, we'll be done with this, and we'll go to another community that the full community can be up to 600 units. And our contractual agreement is for 72 of them, but from what the builder is seeing and what the public is feeding back on this, they'll reward us for our performance. That's all I got to say. They like us, they trust us, and they're great partners. So as we perform, they'll reward that, and good performance equals more work. Yeah,
it's good to have scalable opportunities like that. That's awesome. I got to tell you, I was driving back from California from a video I shot with a group out there, and I was driving through Eloy, so I had to do a couple laps around to try to see if I could figure out where your printed homes are. I couldn't find them. I don't know if they blend in too much. I was looking at the pictures, comparing a few times. I thought maybe that's it, but maybe the garage is on the other side. I can't really tell.
You know, we're kind of a show not tell. We don't talk a lot. And we just do that because institutionally we just keep our head down and keep doing what we're doing, and let the market decide. Right, let the market decide on what we're doing. And right now the market is saying they love us, but I'm one bad mistake away from them not loving us. So I keep focused on that. I know a lot of other people have been doing stuff. So you'll see a lot more. It's out there. If you go through who I'm partnered with, it's all of that information is available online. You just got to click a couple times. You'll find it.
Yeah, I'll always be doing a lot of clicking. Will you have any public facing events or demonstrations coming up in the future?
I'm not sure. Like, I let Jack handle that side of the house.
Sure, yeah.
Again, for us, it's build the product that the folks want. And those folks are the home builders because they have the pulse of the home buyers. I can't even begin to assume to know what they know about home buyers in the market and the mortgage rates and buying down points and all those things. So I just let those experts and they may end up doing some stuff, right? And I'll support whatever they want to do, but unless they ask me to say, look, like, we've done some trades days. Like, so when we do this right now, we're working with a lot of the home builders trades to finish stuff that we haven't pulled in house yet, which we will. So you bring in all the trades and say, look, this is the weird cousin of CMU. This is how you're going to work with it. If you build concrete block houses, this is just 10% weirder. Right. And, so we've done events like that, but it really is, it's really focused on just maximum efficiency for the time that we have. We're small compared to a lot of other folks out there. I think the velocity we have is just absolutely incredible. So those things end up being distractions. I want people to know about it, but at the end of the day, the home builders know about it. They think it's a product they need. They think we fit in really well to that attainable housing market where getting those first time home buyers in, and I let them handle that. I don't want to get out in front of them because that I would crash that. Like, they do it really well. That's their business through recessions, through downturns. So I let them handle that side of the business. They're just amazing at it. So why even try?
Yeah, that seems smart. It's a beast of its own, and if they've tamed it, then let that be.
Yeah. Like I said, these folks are all, top 10 home builders, top 20. They've all ridden through recessions. These folks turn out 10 to 90,000 houses a year. For me to assume I know how to represent that better that's ignorance. So I stay out of their way. And again, this all comes back to the feedback. What do they need to show? So they need to show their sales agents. Okay, we do a walkthrough with their sales agents. They need inspectors. They need their finance people, their insurance people. We focus on that, and they do all the outward facing.
Yeah, and if there is a downturn with rates increasing, that just gives you guys more opportunity to fine tune. I mean, you got 8 of the 27 components beta tested now. Maybe at that point you got 27, or maybe you figured out you only need 20, whatever.
Well, I think the thesis on that is the home builders know, like, the demand is never going away, right? The demand spikes, like rates are killing everybody right now, and that'll do what it does. I have zero predictive ability on that. But at the end of the day, population of the country continues to grow, family creation continues to happen, and you see that. You have 2-3 generation households, have children, parents, and grandparents because of housing costs. And they know that they have to ride through it. And the unfortunate thing that, looking backwards, you saw in 2008 downturn was 400,000 people left the trades and never came back. Wow. They went to drive trucks, they went to Costco, they went to work in factories, they retired early. So if this downturn is short, it shouldn't be too bad. If this downturn is a little more extended, do they lose another 50, 200, 300,000 people out of the trades? And that's just less people to build houses. Less labor means higher cost of house and less production. And it drives all the people at the entry point of the market out. Right. So, for us, they see us as the ability to provide supply. I mean, this is it's a pretty straight supply and demand equation to a certain point. There's a huge demand, but at the entry level point of the market, there's only so many people that can afford a house that costs $250 a square foot. If you're building a 2,000 square foot house and that's a $450,000 house, right? That is really not entry level anymore. So we're focused on being much closer to that entry point of, whatever my home builders are selling for. We work at market rate for them and let them put that house in the market for what they think they can sell it for.
Given your insider understanding of Tesla and obvious expertise with construction robotics, would you be implementing their Optimus bot on a Diamond Age construction site?
I look at all of that stuff, and we've got some amazing roboticists here. Like a couple of guys that just, that top 30 under 30, I would consider them in robotics of the entire world. It's not the right tool. It's something like that. Like Honda had IBO or something a couple of years ago. Putting up sheetrock, doing different things like that. Mm-hmm. It's like people want to see robots that look like humans, but at the end of the day, most robots are pretty simplistic. We use the automotive style 6-axis arm, right? Because it's easy. It's off the shelf. We buy it, we program it. I'm not going to build that. But we use that and then we figure the process out how to be able to handle that 6-axis robot's reach, its payload, and how do I nail with a robotic arm like that, or how do I spray stucco with a robotic arm like that? So just use the tools out there. But the Android bots, the balance. I mean, Boston Dynamics is absolutely an amazing company. With all of the robots they've done. But again, I can solve that solution for picking up a piece of sheetrock or picking up a window. I can solve that with an off-the-shelf robotic arm with the right payload and reach, and I don't need to mirror what a human looks like.
True. The only utility that makes a little bit of sense to me is right now it's built, the way construction is done is organized for humans to do. Mm-hmm.
Yeah.
So that's one benefit, but they're all requiring cranes or some type of way to lift things, move things, reach ladders. Mm-hmm. So a gantry system that has the entire build volume enclosed and can reach every corner seems like why couldn't it do?
And you reorganize the build process. Like, do you get to a point where the roof diaphragm is one of the last things that goes on the house? So you leave the house open to access. Now you have to protect the house from weather as you're building stuff. But at the end of the day, people are anybody in this space that goes beyond just making walls is going to have to learn how to build in a different sequence and to protect that exposed building environment until you get that roof diaphragm on and get that house dried in. So that's a challenge we're dealing with, but we think we've got a pretty dedicated path on that.
Right now, you're sticking closely to what the home builders want in terms of output. Mm-hmm. Is there another path where you optimize for how the robot can build in maybe the most cost-effective manner, ignoring the output?
Oh, absolutely. Yeah. And, the end of the day, it's a trust relationship. So and I think we have that right now. And like I said, trust takes forever to gain, and then it evaporates in a second. So just very, very focused on making sure that my customers truly understand what we're doing and that we stay within their boundaries. But if you call that, take a car factory, it's called stack order, right? You can't put a wheel on before you put a disc brake on, right? So that's something you can't violate in stack order. But I can put window glass in before I put the door seal around the door opening. So that's a stack order you can move around in the process. Or I can put the emblem on a trunk lid before I put the wheels on. There's no interrelationship with that. So that allows me to move those things around in that stack order. And there's a decent amount of stack freedom you have in a house. But, obviously I'm not going to paint before I put stucco on, right? That's just dumb. But, where can you pull electric? Where can you pull your utilities? How do you do those things? So there is some ability to change that stack order to be more accommodating to automation. And that's part of the game. And it's not real hard to figure out. You just have to figure out how you use those tools, how you drive that product to be able to accommodate the stack order. And, my partner Paul says it all the time. He's like, for any operation, there is a minimum number of steps to do it. operation X takes 21 steps. Then we're the most efficient at it if we hit 21. If I hit 45, well, I got it done, but I'm wasting a lot of time. So we kind of look at the house build as what is the minimum number of steps to get it done, and how close can we get to that?
Yeah, if you got the robot working, like if it could do every task in 1 second, then you would just be waiting on the inspector all the time.
Yeah, and the interesting thing is coming from I've had a pretty fun manufacturing ride, but I've built things that made 16 parts a second, right? And I've built stuff that you build one part every 8 days.
You mentioned something with a factory with 5 million units of output.
Mm-hmm. Yeah,
That's crazy.
like bottling, packaging, so like Gatorade, things like that, like run Gatorade machines that 16 bottles a second, right? Just can't see it. But you look at this and you go into a car factory, and like it's interesting. You have car builders and coach builders. The high end cars like Maseratis, Bugattis. Those are all coach builders. Those are bespoke, right? And then you go to Ford and Tesla, and then you go to the entry level market. Like the kings are your Kias and your Hyundais. Those guys are the king of assembly. They build cars with 52-second cycle times. Like the operators, as a car goes down the assembly line, the operator has to do their operation in 52 seconds. They've got to put
It's
a window in.
interesting you didn't mention Toyota.
Toyota's amazing. Like Toyota's absolutely amazing, but just I grew up under the Toyota production system, even in bottling factories. Everybody understands that system. So it's just whatever name you want. All the car builders these days are amazing. Stellantis,
Sure.
they're all really like, and the differentiators are single digits, like a Toyota to a Hyundai to even to Ford, GM, all of those guys. The differentiation is single digit percentages in like operating efficiency and quality. So it's just absolutely amazing. But like I said, you look at the entry level of the market, and you got 54 seconds to put a window in a front door, whether you do it with a robot or whether you do it with a human. And then, at Tesla, we were running 120, 112 second cycles on Model S and Model X. When I look at a robot, I go, look, if it takes me 9 minutes to put a window in and I have 9 windows in the house, that's not really bad. I don't have to be down. I don't have to move really fast. I don't have to have that lightning precision of loading a piece of sheet metal into a stamping press and then barely missing the robot as I grab it just as the press is opening up and risk crushing the robot. That's factory output. We don't have to do that. We have more, minute cycle times. And so it allows you to do things a little bit more deliberately. And, so it's just a different environment when you think about it, how people are going to take these things from just day shift operations to around the clock operations. We have a pretty dedicated path to do that, right? I'm building pretty expensive robots, and everybody else out in the field is building pretty expensive printers. And you want to utilize that machine around the clock. Otherwise, it's just a pretty big capital expense boat anchor when it's not running.
Is there anything interesting we can talk about when it comes to the software? Like, how does the robot see the house over the time of the project? Is there an as-built that's maintained in a brain or something?
Mm-hmm. Yeah, absolutely. Like, so we write all our own software. So I know, I assume just from what I see and a lot from your videos and some other stuff, folks are out there using G-code and slicers a lot. Early on, we said that was not the way to run a robotic system. I mean, we use G-code in our machine shop with 5-axis, 3-axis, mills and lathes and all that. We write G-code all day. We actually wrote our own custom software suite here, a multi-level custom software suite, because this becomes a very, very big part of scaling. This is going to be a software-driven. It is right now. It's a software-driven company. My software team is my biggest team in my company, and we don't think that G-code and slicer really solves it. So we have our own bespoke software. We got amazingly smart people writing code, and but think about that. At the end of the day, in 2026, home builder X, who builds 8,000 homes a year, is going to say, Diamond Age, Jack Russell, here's a 300 home order. I'm going to say, okay, give me the lot layouts, give me the prints. I'm going to need some sort of ingestion process to just take a plan out of Bluebeam or Revit or AutoCAD and run that all the ways down to robot instructions with no human touch. because if you want to impact this market, you need to build 1,000, 5,000, 10,000 houses a year. There's no way I'm going to have a really good CAD operator or structural engineer go, hey, let me see this new floor plan X, and okay, I'll convert this floor plan X into the machine language needed. Can't do that. When you're doing it at that level. So that's where we're working with the software to actually just ingest from an agnostic program, like I said, whether it's Revit, Bluebeam, AutoCAD, whatever people are handing us, and get that robot pathing, get that bill of materials, and then get the sequence of operations all automatically. And I think that's not going to solve with kind of G-code and slicer solutions. I don't know. I'm not working on that end, so I'm really talking outside of something I know. But I've owned and run dozens of 3D printers and programmed G-code back in many, many years. I've done a lot of G-code and different stuff. For what we have to do with the robot and perception, you said, like, how does the robot know where it is? How does the robot know if there's a person on the slab, and does it need to run slower because there's a person near it, right? Those type of things, you need a pretty significant software stack to do that. And I think we're uniquely positioned that we write that code, and we're pretty good at it.
So I guess some of the shortcomings of G-code were the interferences with or changing the toolpath mid-project.
G-code's actually good at that. Like, because if you think about it, you throw a hunk of aluminum in a milling machine, and that milling machine will go and sense the edges, the corners, the top surface, and then adapt the program to that. But like I said, we're not working in that, so I can only infer. But at the end of the day, is that having G-code talk to a camera and having that camera say, hey, what has to happen here? Where are my obstacles? What are my interest points? Where are my intersections of vertical wall surfaces and wall and floor and wall and ceiling? I don't have a clear understanding of how you do that in G-code. I bet you guys out there that do, or that at least have identified that and say how we do it, but it's not intuitive to us. So, we just, like I said, we don't pretend to be experts in that, but we look at it and we go, we think there's some significant hurdles in that, but I bet you there's other smart people out there working on it.
Yeah, and there's all kinds of different, I know your equipment uses LiDAR as well, so that's not going to output G-code, getting all those things working together.
Yeah, and that's a big software play, and there's a lot of people doing amazing things with LiDAR, right? Like, you look at it, and so that's again where I can go adopt and I can license tech. Like, I don't want to, I want to own the whole stack of what we build. I just don't want to have to create it all. And if someone has a good solution, as long as my software team understands it and can talk to it and write the API calls and all the fun stuff to pull information and push information back to it, we use off-the-shelf tech all the time.
Interesting. And so on the flip side of that, if another 3D printing company, one of the other brands said, hey, we really like your truss placing system, can we order one of those for our machine? Would you?
I honestly, I think we have enough of a mountain to climb that I'm, like.
Yeah, I mean, you're not even trying to sell printers, so you wouldn't want to.
No, I probably wouldn't want to do that, right? Like I said, some point in the future, maybe, but at the end of the day, I think it's just really it's stay head down on the product, the equipment, and get the machines out in the field and be able to move them really fast and set them up and be able to train a large number of people that you're going to need to run these things. You start thinking about this, this becomes a military-sized problem. You want to go build 30,000 houses, you're going to need a lot of people to do that, even with robotics.
Yeah, definitely. And it's good to see this technology gets a lot more young people excited about construction than other construction sites. And so it's not as difficult to train the next generation to get involved. I'm sure you're experiencing that as well.
Yeah. I'm gonna have to finish. I got to jump after this, but that's a big thesis in what we've done. Only about a third of the people that we have on our team and our industrial athletes are actually from the construction space. We're bringing people in. The military's absolutely been amazing. Diamond Age is a super supporter of all the vets that have done amazing things for our country out there. You can't throw a stick without hitting a Marine or a Navy guy or an Army guy here, and they're incredibly well trained, incredibly motivated. They understand the team environment. The funny, sad thing is out here that it's a different sandbox they're used to working in. From the last couple of years, we have a lot of combat vets, and they're like, hey, I'm used to sand, I'm used to hot, and if no one's shooting at me, it's a good day. So but we've had some real good luck in, from people all over, from the software world, from the robotics world, people that would not traditionally look at construction. We've been pretty fortunate that the mission connects with people, the company culture connects with people, and the freedom to put your thumbprint, your DNA into an early company that has the ability to go put lots of people into their first home. People love that. So we've been doing really good at attracting people, and there's still plenty more that we're going to bring into the industry. But that's part of this, is not only homes, but good jobs. We really want to focus on having people that want to come out and people that love to work with their hands and create. You're not only just carrying bundles of shingles and using an air nailer, you're loading a robot, you're learning how to calibrate a robot, you're disassembling that robot and moving it 100 feet. So you have this kind of feature-rich job that keeps people engaged and gets them learning. And I think that's key. Give people a job that's meaningful to them, and they will suffer through 118 degrees. And then right now, every morning it's 33 degrees. So, they've got the spectrum. So no, Jared, this has been great. Really, really enjoyed. I got to jump off. I got another commitment right now, but we'll talk again soon and probably have you out to the site maybe after the beginning of the year. But I love what you guys are doing out there. I got a tremendous amount of respect for all the other folks, all my worthy rivals out in the field. I don't consider anybody a competitor, right? There's enough business here to keep us all busy till we all drop dead. And but so a lot of people doing a lot of really hard things, and that's the exciting spot, is to see what people are doing. And to see people saying, "Hey, we all want to put people in houses."
Yeah, that's so true. Thank you so much, man, for joining me today.
Problem.
If somebody wants to work at Diamond Age, they can click on the link in the description and reach out to you guys. Really looking forward to the next opportunity we get to chat. I know you don't do a lot of media events. No. I'm not the media. I'm a citizen journalist, so it's different.
I know you are. I know you, and keep doing it. Keep doing it. We enjoy it.
All right. Thank you, man. Later on.
Thanks, Jared. Take it easy. Bye-bye.